Okay, guys? Hey guys, I think we're gonna get started now. This is really weird. Alright, so welcome to the one of our workshops, which is the automated testing and CI pipelines, where we make sure that our software is without a doubt correct. Okay, let's go through the outline first. So we're gonna be taking a look at the problem with manual testing, the importance of software, consequences of faulty softwares, what's involved in manual testing, introduction to automated testing, TDD and BDD, given when then, what is CI/CD, testing artifacts, and we're gonna leave it off with a demo. So firstly, what is the problem of manual testing? So probably a lot of you starting your career, you're going to be developing softwares, and you're not going to have automated testing. But if you think about it, the reason why we don't do automated testing as much here is the fact that there's not really much of an benefit. But if we take a look at softwares that's going to last for many months, many years, we have to make sure that when a code base grows over time, is the fact that we have to make sure that existing portions of our code base still works. So it kind of looks like this as a graph. So firstly, your manual testing, you're not going to have a lot of costs. But over time, as you grow your applications, you're going to have to click every single button out there. You're going to have to test every single scenario that might happen. But let's think about this in our case. Our application starts with one button. But then a couple of months' time, it's going to have maybe, 20 buttons. And then there's different combinations that you could press them. Like, it just grows enormously. As a human, we're going to make sure that this thing works by actually doing it ourselves, which takes time. Let's say, for example, a human takes maybe 5 seconds to decide which buttons to click and to evaluate whether it's correct. A machine can probably do it like a fraction of a second. So in terms of a business perspective, it looks like this, wherein our automation testing kind of has a lot more cost and investment to actually build it up. But over time, the cost actually gets lowered, because for manual testing, the amount of things that you just have to test keeps increasing. While automated testing, you just add more test suites. So it's tedious. And furthermore, some scenarios are actually hard to repeat, especially when you're doing simulations. Like for example, how do you actually test what your application does whenever you lose internet? Or whenever the database randomly crashes? Like you can't do that as much in an actual environment. Because to do that, like for example, network issue, I'm going to be performing some scenario, and then I'm going to cut off the network by activating a firewall and access. So that takes a lot of hours. But when you do simulations in terms of testings, that code and testing can actually run in the pipeline, which we'll see later on, and takes like a couple of seconds instead of hours. Furthermore, it's repetitive, because you have to do this type of testing every time we make a change. And then there's a growing number of scenarios. And as I've said, it's time consuming. As your code base grows, there's more tests or scenarios that needs to be tested. But before you could see the importance of testing, we have to take a look at first the importance of software in our everyday lives. So like for example, our power plants, control systems, we have softwares that are in place to make sure that the conditions at the power plant is in a safe working condition. We have healthcare, for example. Like these days, we're going to have, actually, an example of that is probably Telstra, which built an application in terms of optimizing the path at which an ambulance goes to the nearest hospital. So that's a practical example. Transportations these days has been emerged by technology and softwares. Like for example, you have your airplanes communicating with another air tower stations. Those are coordinated by softwares that happens. In our daily lives, we have our alarm clocks. Actually, something related to transportation as well is, these days we have Uber. We could just call it transportation at our convenience. We also have a fair bit of office work. We have Microsoft Word, Microsoft Presentation, and also education. Like, we've revolutionized the way wherein people that don't just go to the library and just read books. Everything is accessible online. So this is where software comes really far in terms of its value, in terms of our lives. But something about software is the fact that it's very fragile. Like a single line of code or a single character can be the difference between your code that works and it could be the difference wherein it causes injuries. So let's take a look at the consequences of our faulty software. So firstly is huge compute charges, If your code doesn't work properly as you might have intended, it's the fact that you might have been running infinite loops around cloud computing services, wherein it just scales automatically. And before you know it, in just a couple of hours, you owe AWS like $1 million. It's also embarrassing if you think about it. Like, what are you going to tell your boss if you're going to say your entire servers or services crashed because you accidentally you accidentally put a semicolon at a place where it shouldn't be? Could be a cause of disruptions, taking down a servers and services for like many hours to come when a lot of people rely on it. So what if, take a look at a scenario, what if Google just randomly crashed for like many hours? People like us, we can't search a Stack Overflow, so we're gonna get stuck in our problems. You have user frustrations, and we get that a lot. Wherein some person just wants to watch YouTube and they can't because it's just the servers are not running. You also get client loss. And in these days, our software delivers a lot of value. And if our client cannot cross on us being able to deliver that services, we're going to lose the client. And probably one of the biggest factors as well, if you're dealing with safety critical systems, you can cause a lot of deaths and probably a lot of disasters in softwares. A single line or maybe a portion of your code base can be the difference in an alarm that doesn't ring for the next Chernobyl accident. So yeah, so let's just think about, in a way, the fact that softwares, they have a lot of importance in our lives, but it can cause a lot of disasters as well. So I don't want to make this thing a little bit morbid. So let's take a look at a much more warm in terms of mistakes that happens in productions. So I think you might have heard of this, where in HBO, they've accidentally sent test emails to customers, and they said it was the intern. But, we have this very good engineer that says, dear intern, it's okay. I dropped the production database when I was a senior engineer. These things happens more often than you might think. And and I can tell you, it actually does happen a lot. Because, to build good systems, it's having resilience against human mistakes. And if you think about it, all our developments happens with humans just making mistakes. And I think you might have a short glimpse of what's going to come in the next slides about resilience against human mistakes. So how do we actually become resilient to human mistakes in terms of our testing of softwares? And one thing we could do is probably automate it. But before we do that, let's take a look at what's actually involved when you do manual testing. So let's just look into a much more broader perspective. If I want to test a certain code or a certain feature, or maybe it's just a couple of lines of code that a coworker sent me, this is the 5 things that I have to do. Firstly, I have to open my environments and tool, my VS Code and all sorts of things, Postman. I have to do a Git checkup of the change that happened. I have to install dependencies if there's new dependencies that happen. And then this is probably the one that's going to take a lot of time. Setting up the environment. Do I need to clear the database? Do I need to enter a couple of data, some fixtures, to make sure that my code works because there's data there? Do I need to disconnect the server while the server is running? So all these things require scheduling, setup, and it takes a lot of hours to do. And then once you actually try to set it up, you perform the steps to test. And I can tell you that this is probably a lot repetitive. You assert the test correction. Furthermore, you have to make sure, did you actually make a mistake while you're testing this? Because if you make even just one mistake, it invalidates your test. So you actually have to go back and redo the entire setup. And now, that's just for one test. Now you have to do a different scenario. Repeat this thing again. Okay, hang on a second. What if your coworker actually forgot to push one of the changes? Now you have to run the test again. So this is all very repetitive. And, it's really hard to make sure that every test case scenario works. That's why a lot of developers just read the code and says, this code seems correct, but not actually going through all the steps. So yeah, I read my code, it just seems fine. Developers. So yeah, it's not that efficient. Think about it. In a case wherein you have a growing code base, you don't have automated testing. Now you have to test, like what I said, the buttons that have just been created. So I think this reinforces what I said in the previous slide. It's tedious. Some scenarios are hard to repeat. It's repetitive, and it's a growing number of scenarios. And furthermore, it's time consuming. So let's take a look at automated testing. So what's actually involved in automated testing? Firstly, you write the scripts to evaluate the code. Next, you write script to run script when certain events happen. And I'll talk about that later in CI pipelines. So next, whenever we create code changes, we update the scripts whenever there's new things that happens. So it kind of looks like this. So in just a couple of seconds, you click one command, PyTest, as an example here. It's going to take a look at all your test cases and also runs it. And this happens in just a couple of seconds comparatively to when a human is going to run it. It's going to take a couple of hours. Because think about it, one test case scenario probably takes less than a second. If a human tests one scenario, it's going to take maybe a minute. So yeah, it goes a lot. And the good thing about automated testing is the fact that you can run this automated testing scenarios even if you just add the semicolon or add a new character in the string. So here's something to point out. This is also known, unit tests or test cases are also known as what's called regression testing. Regression testing just is what's called testing the existing feature which proven to be correct. Because the thing with software is that you want to make sure that your code is correct, but not just correct. It will continue to be correct. Because software evolves over time. Requirements changes. So you have to make sure that even though the requirements changes, the previous specification that you said your software is going to do will still be able to do that. So now let's take a look at different ways. So automated testing. Now, how about the different approaches to actually doing automated testing? So there's what's called test-driven development and behavior-driven development. It's a type of practice where you define the test or specification before actually writing the code. Then you write the code. So here's an example. Probably you know this from 61402, 61401, where I think the project doesn't change as much. It's the fact that they want you to read from a CSV file, and then they want your CSV file to output a certain arrays of things. Now let's take a look at this from a manual testing perspective. I write my code, make sure it's correct, by taking a look at every single element in that array to make sure that what they said in the PDF handbook, that it's correct, matches what my code output is. So it's a little bit repetitive. So the good thing about automated testing is the fact that I could just say, this is the correct output, and just the only thing I have to take care of is the fact that does my code have X marks or check marks in terms of its testing. But I have to acknowledge that this type of approach of development, it does not always work, especially for when you're dealing with front end, because you don't exactly know what your output is going to be. In contrast to our waste project, you technically always know what your output is going to be in terms of your endpoints. Because, like for example, your GET request, it will always have this type of fields that corresponds to your database. Whenever you post something, it's always going to have a status code 201. So if you've done a lot about API developments, you're going to know that the HTTP error codes are like standards. They don't change. So you know that in terms of when you do test-driven development, you always know that this type of scenario will output this thing. So that's where it works a lot. Yeah, I have a video here by Fireship. Let's watch it. Ah, man. This is a little bit weird. Doesn't want to play it. Just go to YouTube. Oh, not bad.
So what should you guys have? So what should you guys have already?
And it's
Going to be great, right? Well, yeah, but everybody wants to help.
Software. It's not like engineering something easy like a bridge, where you start with a blueprint, build a spec, and then forget about it. Software is dynamic, but they have a lot of moving parts and requirements that evolve over time. Developers build apps on top of a mountain of abstractions, and nobody fully understands how everything works. That's okay, because we just need to make sure that our code matches the requirements of the product. Test-driven development is scientifically proven to reduce defects and improve maintainability of the code base, but it does require some additional effort. One option is manual testing, where a human being clicks on every button and fills out every form, then assigns a bunch of Jira tickets so they can be backlogged by the developers. But that's not very efficient for a large-scale product. A better approach is to use automated testing tools that allow developers to write code for the sole purpose of testing the main application code. In a code base, you'll often find files that end in .test or .spec. Inside, you'll first find a line of code that describes the feature or thing that's being tested. That's known as a test suite, and it contains one or more individual tests. An individual test usually starts with it, followed by a description of what's being tested. The idea is to describe the behavior of the code in human readable terms. Inside the test, the code will be executed, then one or more expectations or assertions are used to check that the code produces the expected result. If the expectation returns false, then the test fails. If it's true, it passes. Test runners like Jest or Karma can run all your tests automatically in the background or on a continuous integration server before you deploy. Now, there are many different automated testing strategies that you should be aware of. At the most granular level, we have unit testing, which is designed to test individual functions or methods, like does this function return the proper value when given the arguments of A and B. Then we have integration testing to determine how well different components or modules work together, like is the component able to use the database service to get data from the server. And at the highest level, we have end-to-end testing, which usually happens in a mock browser or device and simulates actual user behaviors like clicking on buttons and filling out forms. It's like having a robot to do all your manual testing for you. And that's not all. There are many other types like performance and smoke testing, which I'll explain in my upcoming test-driven development breakdown. Hit the like button if you want to see more short videos like this. Thank you.
Okay. I think that kind of sums up test-driven development. And also something that you might have seen for that one is it's using, the syntax is using what's called behavioral-driven design, wherein you have describe, where you describe what the test suite is about, and then it, basically what it tests. So let's go further. So given when then is probably one of the common methods in terms of testing. It's basically given when then is what's called an acceptance. It's to describe a user acceptance feature and can always be divided into 3 different parts. Given, so you state what your assumptions here, when, for a particular scenario of occurrence, and then the effect or observation. This is usually the type of pattern that you're going to see whenever you're trying to make sure that your code works. So let's have another video because this is very related and sums up in terms of CI/CD. So CI/CDs are just scripts that runs for certain events, such as a pull request, a commit. And the reason for you want a certain events to happen is so that you could run tests or you do deployments. So I think from that video, there's a couple of things in terms of the CI world. There's the GitHub Actions, Circle CI, Bitbucket Pipelines, and Travis CI. So this is essentially places where you could write a certain script to have to accommodate a certain event, like for example a pull request, and then it runs your tests and also maybe deployment for you. So what's usually in a CI? Firstly, you're going to have linting. So linting is there for code consistencies, and also it probably can help you detect early code problems in the development. Like for example, it can find undefined variables for you. So linting is also known as what's called a static code analyzer, because it just takes a look at your bare code. It doesn't run any tests. It just takes a look at code and see if it even compiles. Then we have tests. Tests requires you to write your automated testing suites, and then you can run those tests, then build and deploy. Whenever any steps of this thing fails, it will notify any developers that are involved in that pull request. So you're going to get emails and notifications that your pull request is not working. Furthermore, there's probably a couple of things that are in CI pipelines as well, but these are probably the three main bits. Some bits that you might have as well is the auto tags issues, security checks, and you might also have code auto suggestion. It's like linting, but it suggests like best practices on this particular code can be redesigned this way. It's probably one of the foundations of GitHub Copilot as well as the recent one. Okay, something as well in code automated testing is we have what's called testing artifacts. We have files that when we create tests, we get a couple of things back. We have what's called a coverage report. Looks like this. A coverage report tells you which line of codes are run whenever you run your automated testing suite. So you can detect places where you either don't have a testing that accommodates that, or that code is unused in the code base. And unused code is probably not as important, the code, but it adds to some hassle with the developers because they don't know if this code needs to be maintained. Something you also get is screenshots of videos, or videos of failing tests you get. Like for example, when you do Cypress, it's gonna show you a video of the test runner actually doing your actions, clicking buttons, typing keywords, and also when it fails, it shows you exactly where it fails and also a screenshot. Something you might also see is what's called a long-term test reports. You can take a look at trends at which certain tests are running. You might even detect what's called flaky tests, where your tests, automated testing just fails for some reason. And you can see some trends with that one. Alright, I guess that wraps up the main work. Let's go to our demo. So going back to one of our workshops is the software engineering practice demo. Probably one of the demo where the CI pipeline failed in terms of our development. But I revised it yesterday, and I will encourage you to actually go to the GitHub repo. Either do all sorts of things. You could add more test suites. You could you could remove some tests, and take a look at the check marks and X marks in your pull requests. Yeah, I encourage you right now to do that one. So, going here, I have revised the file structure of that one. As you know, you have the main.py, the main operations, which is the utility functions, and your testing codes. Something that you could see here is that a couple of our pull requests are failing. So if some of you wants to fix one of our problems here, that would be great. But actually, let's take a look at one of the actions that I've run. So this code base is now fitted with two main things. It's fitted with linting to make sure code consistencies, and it's also also fitted with what's called automated test suites. So there are 5 suites. Something about this is the fact that you also get what's called artifacts. I fitted it with a coverage report, so you know which line of code has been run, and you can download those artifacts. I don't know why I can't download it. Yeah, I think so. I may need to sign in for that. Alright. It's probably a good idea to experience the CI pipeline for yourself by creating a pull request, any change you want. Exactly. It's going to detect whether it's a failure. But firstly, try to address one of our problems. First is the multiplication. So as you know, with one of our demos, wherein we have a failing scenario for one of our operations, which is multiplications. Because somebody wanted to merge an operation that looks like this. Yeah. Yeah. This is the interactive part of our workshop, so probably a good idea to feel what a CI pipeline actually does. And I'll explain the CI script that's embedded here. Because this is not my laptop. Okay. Can I just have your attention in a second? So this is the coverage report that is attached to the CI pipeline. So whenever the test runs, it will generate this. So if you added more test bits, it's going to regenerate this, and you can download it to the CI pipeline. And as you can see here, if you take a look at the test operations, there's a couple of bits here that did run. These are the two. That probably means that this actually failed in terms of its execution in tests. Take a look at this one. So it looks like everything here ran. Take a look at main.py. We only really have test suites that runs for this particular code lines, but not this one. So as you can see, it's pretty cool, as you can point out which part of the code that doesn't run. Here's another bit. Yeah. I encourage you to raise pull requests for that one. absolutely any change that you want. Just send it over to the pull request, and you're going to see it's either an X mark or a check mark.
Oh, you're gonna Oh, nice, right. What's that supposed to do with
The software engineer practice. If you want to fix it broken in the pipelines, remove it. I think that's our strategy. And there's one of those operations actually, you know, they just change it there. Yeah, you can. Yeah, you know, the only thing that I'm going to change yeah, readme, you know, like stuff that you, it will know what you I'm not Larry about it changing anything. Yeah, actually, I will leave that up. I'm not that much but in terms of just general, more confident, this is not for investments. So I go to you. Yeah. So I usually use so like I think in terms of purpose of business, it's demos, it has to go automate like I would say that the integration is like when I got some of my share. That's cool. I have to set up my yeah, that stuff like that. Yes, so that's literally exactly these exact problems that that's what made very confident. He's got this fine. Let's take a look at one of our champions over here that has created a fix for the problem in CI pipeline.
Frinze, did you add the teams to the repo?
Yeah, except non-player.
Because people can't, that does seem to have the rights to it.
Sorry, I'm being dumb.
Yeah, I'm pretty sure.
Yes, I'm being dumb.
You have Frinze that's
Alright,
So no, you need to say
let's get back to our topic over here. We have a champion over here that has fixed our problem. Take a look at this. There's checks everywhere. So there's, it looks like he passed our linting stage. And he also passed all the test sheets right here. So a couple of tests that has been run. And if we take a look at his coverage report. So, right over here. You can download this coverage report. Let's save the file. Oh, let's extract it.
Yeah, sure, yeah. Okay.
If you take a look at this, what used to be red lines over here is now green lines. And also, this part, test operation, used to be red lines.
Yeah.
Alright. Anybody else that's wanted to try the pull request? We're trying at the moment. Otherwise, let's move on to how this CI pipeline runs. Take a look at this. We have another test. Yeah. Looks like there's this guy. He added a new test suite. New test case. But he also added inconsistency in the test. And as you can see here, it also gives you a comment on which portions of the code that has inconsistency. As much as possible, like for example here, we have linting that allows code to be consistent, such that we don't introduce unnecessary changes in our code. Like for example, as you can see here, we have an extra space. Currently, you might think that this is not as important as you would say. But let's take a look at in this case in our scenario. A software developer just added a tab across 100 lines. Now you're going to see a lot of red and green lines, and it's hard to take a look at which are the important bits in terms of your change. This is where linting comes really useful because it takes a look at where the inconsistency is so that it can be fixed, and whenever you're adding more code to your code base, it always follows a certain guidelines. Yeah. Yeah. I think the developer over here, you can add a new change to actually fix the pipeline. We're getting more changes over here. So you see, as a developer, I have confidence that the code works simply because of the new the test runners that runs here, as well as just looking at the code. So it looks like here. Yep. According to this one, it's failing linting because it looks like the changes has already been done. So because the changes already been done, I could be confident that in terms of code consistency, it adds a little bit of inconsistency because it just adds some spaces, and it's not as an important change. So I could post that. fix test. It looks like this. It has a, yeah. As you can see, automated testing, it really saves us a lot of time because I just look at the change and takes a look at the test that runs, and also I just take a look at the code. So I don't have to worry about cases wherein I have to inspect every single thing. I don't have to inspect whether the code works. Actually, like, I don't have to go to your branch, hit checkout, install dependency, and also run it. I could just rely on my integration pipeline to say, this code works. And it saves me a lot of time. And it's also probably important whenever you're doing what's called dependency updates. So an example would that be, I think it's food bank. So if we have automated testing that runs in, so whenever we have changes that looks like this one's, update dependencies, whenever you have check marks, you can be confident that a certain change is correct if a certain checks runs correctly. Yeah. I think that sums up the demo part of this workshop in terms of interactive CI pipelines. Now we can take a look at how does this actually work in the first place. So we have one file here called CI.yaml. It follows the same syntax as the Docker compose YAML file. Looks like this. So according to the configurations here, the CI pipeline will run for particular scenarios. Whenever it's pushed at a branch that has a name main, whenever a pull request has been done, or whenever I dispatch a workflow task. And whenever these events occur, these scripts will run. So I have two scripts here. Firstly is the click 8 pipe. What it does is that it checks out our code, sets up Python, installs Plate 8, and also runs Plate 8. Next, for the automated testing part, takes a look at this strategy matrix. So you can test at different versions of Python if you add more Python versions there. Runs on a certain image, and then we have steps that happens there. We have this portion of our code, sets up the Python, installs the dependencies for our case, and then it runs our test runner, and it also outputs an HTML coverage report on the files, and then it makes it as a downloadable file in our pipeline. So that's the reason why for every pull request that has been raised here, it's going to have our coverage reports and also some things, linting and also fixing of the tests. Yeah. I think that's ends our workshop. 12:15.